going to start out by assuming that the answer to the question, does data science have a real impact, given to a room of people who are dedicating the one life they have to data science, is probably yes. So now we're going to try, okay, that's resolved. Now we're going to try to get into what exactly is that impact and how do we size that? And I think it's an interesting question because many of us are led into a bad place right now. And I want to talk about why. Just for a minute, and then we're going to get two sides of the question addressed. I think to abstract what data scientists do somewhat is pattern finding. And this is obviously tremendously important because there is no advance in nature studies or science or engineering or art or social observation that isn't essentially based on finding a pattern, surfacing it, augmenting it, making it more efficient, what have you, but finding behaviors that can be seen. Every scientific discovery is this thing. And we're in the golden age of pattern finding now because of technology. And the reason it's become really manifest in our time is obviously it's become very, very cheap to store lots of stuff, and just keeping it is cheap, having to do with software and hardware advances, but also it's really cheap to find and score a lot of stuff. And obviously the first great advances in this, as businesses at least, were from Google and Yahoo. And it was via the browser. We were able to just gather and store tons of data about where people were going on the internet and what they were looking at on the internet and what they might buy on the internet and what they were reading on the internet. And then you could go to those sites and tag them and derive information around them and how far they were reading, all this stuff. And that gave those companies, Google in particular, really interesting advantages. One of the most dramatic was probably Google Translate, where in just 1 year of looking at websites and mashing them against each other, they were able to do translation work better than 30 years of linguistic theory and computation had been able to do. Just pure amounts of data they were gathering, triangulation of meaning into translation, brute force killed it. And that was great. But their daily bread and butter, of course, is advertising-derived search. And this was also wonderful for them because they could see where people were going. They were also looking at their competitors and figuring out how they were pricing. Remember when AOL released all that user data that was anonymized? And people gave them all this heat because it actually wasn't anonymized. You could figure out where these people actually were in many cases. Well, for Google, it was actually much better than that because they took all that data and figured out how much it was costing AOL to derive those searches and worked their own ad pricing against it. And so priced so that every ad that went up against AOL would just be a little bit too expensive for them and kind of drove down any profitability out of that. And that's a small example of how cleverly they were using data to leverage up their abilities. Now, we're at an interesting phase where that mindset has swept over how we think about data science. And the internet is no longer a thing you use or a place you go to. It is essentially an overlay in the physical world. It's being deployed everywhere, through sensors, through phones, through cars, machinery, you name it. And the mindset around much of this is still oriented towards Google-type behavior. But it's not clear what patterns we will reveal, how that data might be derived, how it'll be tagged and organized, and what those patterns will be worth, or really what the interesting questions might be that we could raise. So I think there are pricing issues and there are value issues that have yet to be resolved as the internet becomes an overlay in the world and data science is deployed everywhere. We have two opposing views on the various advantages of it. Jari's going to talk first, and then Dan will talk. I hope we also make this interactive very quickly with people from the audience throwing in because there's so many smart people in this room. So Jari, why don't you?
Okay, thanks, Quentin. Good afternoon. First, Kartik, apologize for not being able to be here. He's sick. We work together at Twitter. He would be a great addition to this panel, but he's home in bed. So how do I change? Oh, I can use this. Right? So What do I need to do here?
Technician. He can run the world's largest data.
So while he's figuring that out, so let me just first explain to you why I think I can have an opinion on this topic. So I've been very fortunate to work in a couple of jobs where I've been applying data science pretty broadly. I first had my own company that was doing that in a social enterprise collaboration space. We identified experts and documents that we recommended and so forth. And then I did that at Salesforce. Then I worked with predictive analytics of big data for marketing, CTO, when we applied machine learning algorithms to fine-tune marketing campaigns and recommendations on websites and so forth. And then I was working with Twitter, running their data platform, where we tried to actually apply our own algorithms to optimize how we compute so we could reduce costs. So we've been trying to use these kind of algorithms in many different settings to essentially create a competitive advantage. And there's a lot of hype about it. I'm going to tell you about a couple of stories, but I think in the end, I'm going to tell you that I actually think that there's many more cases where it doesn't apply. You don't get a competitive advantage at all, and you guys are going to be instrumental in actually helping the world get the advantage that we all believe we're getting from data science. But a couple of examples, successes that I've been involved in. I worked with HP where they did something called shared wallet analysis, when you try to predict how much different businesses are buying and how much you as a seller have of their business. And we worked with a $5 billion SME division, and they claim that they increased their revenue by 3 to 5% by using that software. So it's obviously a huge success. Another example was a company called Mavi, which is a jeans company in Eastern Europe, in Russia, where they were doing promotions across all of their customers. There's like a Gap out there. You probably don't know about it, but they're like the size of a Gap. Promotions across all of their customers. And the problem was that they gave promotions to people who bought even without promotions. So they cannibalized their own market, which means they lost money on every promotion they made. By using this kind of analysis, they were actually able to detect that, and then they could target the market to different clusters of users and actually increase their revenue. At Salesforce, I had some colleagues who looked at database transactions and tried to categorize that with data analysis and see which ones take a long time and require a lot of hardware resources, and then just essentially just cancel them to reduce cost. So, and then retry later when they had spare capacity, right? So that was a reduction of cost kind of thing. Does this work now? Yeah. Okay. So I wanted to give you a couple of examples of these. So that was a decreased cost example. For user engagement, of course, you can. I worked with, especially at Salesforce, with different algorithms to have different recommendations and so forth in applications to actually have users engage more with the application. So there's a lot of success stories out there, but there's a lot of problems. I've seen a lot of problems where actually you lose money by using data science in a wrong way. One example is this. So at this predictive marketing campaign company, we were selling the fact that, hey, you need to predict when you do email marketing campaigns who will churn if you send them another email. So there's a lot of customers, like if you send an email, they're just going to get fed up, they're going to actually unsubscribe and going to leave your site. So we went through all this modeling and be able to predict who's churning. So don't send emails to those guys, but they're just going to churn. But in the end, that was completely wrong. Afterwards, we showed that we should have just continued sending emails because that actually gave us more revenue in the end. So even if we optimized churn, we didn't optimize for revenue in the end. So just sending the emails generated more revenue than trying to predict who's churning and try to filter out how we're sending emails to. I've also been involved in where you try to optimize your recommendation algorithm on sites, and it's actually shown that you then decrease your revenue because in one example we were started to recommend other similar items rather than just the most popular items. And completely unintuitive, but it showed that actually reduced the revenue. And the problem with all these examples, there's a lot of problems with these. But other things are like the quality of data will impact how well you can do your analysis. There's bias in data. Most data scientists in the industry today don't even consider bias in data. They just do their models and then they assume. There's a question about the names to Ali today. It's a great example. You kind of assume that the data is correct, but in the end you draw a lot of wrong conclusions. They're missing values. Normally people don't know about their underlying data. They're missing values. You build models and things that show to be completely incorrect because you don't know what you actually have in your data. People they think they see something that's significant, statistically significant, and draw conclusions and build a model and application based on it, but it's shown that, afterwards shows that it's actually not statistically significant. The other thing is that you optimize, you have your application, and maybe the recommendation example is a good example. You optimize one part of your application to drive more clicks, but that would then cannibalize on other parts of your application. So in the totality, you're actually reducing the engagement for your application. So this is kind of my very weird way of trying to drive home my point. But what I'm trying to say here is that once you go through this data science exercise, there's a lot of things you need to consider. First, are you based on intuition or not? If you are, then you go down, this is kind of a decision graph. Then you go into the red box immediately, you're gonna fail. It's shown that if you go based on intuition, you're gonna come up with the wrong model 95% out of 100, right? So, but then you can then you have assumption of a model, then you need to build a model. Then the question is, are you building the right model or not? In most cases, no. And then do you understand your data? Do you know that you have missing data? What data is missing? Yes or no? Most cases, no. So I would claim that out of whatever we have here, 20 end results, one will be successful. So my point is that in order for data science to be creating competitive advantage, we have to have people who really understand what's going on from data up to the algorithms, to the business model and the whole application. Otherwise, we're not creating competitive advantage. We can actually create disasters. There are examples where engagement with applications being gone down drastically, and actually when I was at Twitter, so a lot of the effort goes into doing experiments because they're dead afraid that monthly active user number will go down because they released a new feature, right? You don't know. If you just release the feature, you wouldn't know. It's really hard to predict. So those kind of experimentation techniques are going to be absolutely crucial for us to create a competitive advantage. So that's kind of my take on it.
So I think Jari set up kind of an interesting straw man for me, which is to some extent, if there's real competitive advantage in data science, it's all about the people. I think that's some of what I took away from it is have people who are responsible enough to understand not to base themselves completely on intuition, not apply the wrong model, and think holistically about the problems. I can't say that my tenure in the data science space is quite as illustrious as Jari's. I came originally from Howard Hughes Medical Institute into the startup world and then into the world of very large enterprise technology, which is still quite weird for me. But before I address the question of is there real impact, I had to be honest with myself and unfortunately honest with a room full of data scientists and say that for me, the term is an uncomfortable fit. It gets applied to me from time to time, and I suppose I can understand why. I still write code, I still publish papers, and I do on occasion have opportunity to help very large enterprises analyze their data. But I feel quite disingenuous calling myself a data scientist, and that's not only because the term data science feels a little bit like the words chai tea to me. What is a scientist without data? If nothing else, I'm a reformed scientist who uses computers to aid in discovery. And that might be basic research, or it could be value to a business. It could be an online business. It could be a CPG company that's trying to sell you more paper towels or make a better cleaner. And I would rather we call it scientific computing. Unfortunately, I think that term has largely been adopted by earlier researchers. But as I was trying to prepare for this panel,
I thought for a second, what were we doing before we were doing data science, before this all became a thing? And I think I've actually come up with what I feel is a valid answer. We were doing accounting. If you look at the way technology was applied to data sets in large industry, up until the very recent future, or the very, very recent past, we were mainly doing accounting and actuarial studies, and some science, but largely it was about closing your quarter. It was about reporting KPIs to businesses. And traditionally, that's because the cost of doing science, and any of you who suffered through graduate school or are currently suffering through graduate school know this very, very deeply, that the cost of science is probably greater than the cost of accounting. But increasingly, and I think Quentin addressed this well as he introduced us, the cost of compute has gone down. And very specifically, our access to methods has increased dramatically. Jari mentioned the sort of dangers of intuition driving you to the wrong model, or the wrong choice of method. And it's very interesting. When I think back to the first time I had to write a neural network, I had to go dig up a dusty textbook and sort of figure it out and take the pseudocode and go write it. And now, if I want to do a CNN or something like that, I very easily go to GitHub and I can find 18 different ways to do it. And that's great. I have greater access to methods. And that means that I minimize the cost of science tremendously. So I'm very glad that we've moved beyond accounting. And I think that's how we got to data science. And I actually do think that data science is a thing. So if there's a real advantage, so what? If we got past accounting, so what? And over the past few years, I've had the opportunity to look at how old businesses look at data science, how your insurance company looks at it, how your credit rating company looks at it. And I asked myself, does data science transform businesses? Yes, sometimes. And to Quentin's point, when you look at Google or Yahoo and some of these companies that have staked out narrow competitive advantage, it definitely does. Although I think there are many pitfalls organizationally beyond the pitfalls of the modeler's intuition, the modeler's experience. It's not a replacement for accounting. Accounting still matters, and that's great. But I think it's less about the technologies and more about changing organizational disciplines. One of the most complex scores I can think of that's attached to a human being, beyond the car scores that Automatic is producing, is your credit score. And generally speaking, of the rating agencies, does anyone know what the most fundamental piece of technology in computing your credit score is? It's almost always an IBM mainframe. Almost always, still to this day. And so, as the technology changes, it's opening up not only access to the ability to do new things, but it's causing organizations that are going to move technologically more slowly to consider changing their organizational disciplines. And quite a lot of what I see is large enterprises interested in how they can make that organizational shift, that cultural shift. And it does become, I think, a real advantage if, and have real impact, if we're talking about competing on data, and Quentin alluded to this to some extent. More data, better hyperparameters may mean, in fact, a slight advantage. And I think real impact is going to increase as we begin to see people treat data almost as if it were a form of capital. And do we see things like hedging of data? And I think it ends up being as much strategy as it is science. But if does data science have real impact? I think maybe the question, at least for some of the people in the room, is what about me? And so I asked myself also, does data science change careers? Is there real impact to one's career from data science? And I think definitely, actually. I think increasingly careers may be described as a job function and coding, a job function and analysis. And I think a lot of the excitement around, what people in this audience and more broadly people in the world are doing around data science is that these new qualities are becoming central to business and thus central to careers. Some new appreciation for analytical savvy, for computational know-how, and for being able to think holistically while still understanding how to apply the scientific method to data. And I think data science is letting ambitious people blaze new trails. I think if you look at someone like DJ Patel, who would have thought that we would have a chief data officer for a country? And I think there's that opportunity for many, many people who are ambitious, display this kind of desire to gain savvy or to apply savvy, and then realize that some of this is about science and some of this is about art and culture. That's all I really had, except for a summary, which is, so is there real impact? That's my take on it, at least. For some, yes. For some businesses, yes. In many industries. Not all companies, but many, many industries. And I think in increasingly many individual careers. But I do think that there's a very long tail to the notion of real impact. Science itself can take decades to institutionalize. Anybody who's published a paper recently can think back to when they wrote that first draft. And how long did it actually take to see it appear in print? And I think we should expect exactly the same from data science. I think there's a very long tail to the way this is going to change the way we work and the way we run our businesses. Thank you.
All right, thanks. You actually end on a very interesting note, because it may be that right now, with this automation of so many collecting behaviors, we're really in the arbitrage years. You know, we're finding more efficient ways to do existing things. And really, my father was in the direct mail marketing hall of fame. And everybody's got one, but like junk mail fed me as a child, okay? And I looked at Google and was like, wait a minute, they show up and they tell you what they're interested in, and then you don't even have to put postage on the ad. You're going to make a fortune. This is fantastic.
Margins are great.
Yeah, they just crush direct marketing, right? And then my industry they came for, and Craigslist came from it. But that's essentially arbitrage of existing things. And
absolutely.
And that's great. The trick is understanding the existing thing in some ways. And I wanted to ask you, Jari, that 1 in 20 outcome, that's like bad, right? And the way you get up to sort of, I don't know, 1 in 15 maybe would be to better understand the kind of question you're asking and the process your company has, to have this holistic understanding. Is there any way to sort of move beyond, the arbitrage age into the insight age and sort of the novel new behavior age by creating software or patterns of instruction that help people choose how to ask questions?
Right. I mean, right now I'm working on a product for Oracle, a cloud product that does a little bit what Databricks does. It tries to put data science in the hands of business analysts. Right, but it's really difficult. I believe that it might happen, but it's going to be really difficult to make it so automated and so easy to use, so anybody could just gain valuable and valid insights from data in an automated way. But of course, technology is getting there. These machine learning platforms is getting better. But I think one other key thing is that in order to actually derive good results or good valuable insights, you kind of need to understand the whole flow. Just doing machine learning thing is not sufficient. You need to understand statistics, you need to understand how to clean data. And so in a previous job, I hired statisticians as data scientists, but they immediately trained them as programmers. Right? They need to be good programmers, be able to go in and dig data, do their own cleaning algorithms. If we can simplify that over time, I think we can put this, this power in. But I think it's going to take a long time. That's kind of my.
I mean, I think there's an end state that's actually quite interesting. You used to put and said that what humans do is pattern recognition, and it is in fact what as a species we're very good at. And I suppose what the end goal is eventually is to make things so declarative such that we can present something to a user by which they can discover a pattern, because some of that is hardwired here.
Right, but it also needs to be, it needs to be done so that you as a human can feel confident in that the insights you're seeing, Let me give another example. So we were actually doing a sentiment analysis tool for this product at Oracle, and people were complaining that, hey, I don't know, what is the quality of sentiment analysis? So now we start to expose them to confusion matrices and stuff like that, so they can actually get some kind of qualitative measure. So of what is the quality of the analysis that we've done for them. I think those are the kind of the validation aspect. Those are the things we need to work on too. because even if you as a human can recognize a pattern, if you don't understand,
You have to recognize a confidence interval as
Yeah,
well, right?
exactly.
And maybe that's some of this notion of we as a workforce will become more analytically savvy. I mean,
Right.
I don't know how many years I've spent complaining that people don't understand to put confidence intervals on their bar graphs.
right?
Well, in some ways, what you're touching on goes back to a real age-old problem in computer science, which is AI versus IA, artificial intelligence versus intelligence augmentation. Is the job of computers to recapitulate human processes better than humans possibly can, or is the job of computers to seek out ways to assist humans in things humans are inherently good at? And I'm going to go to like my Robert Goulet moment now and reach into the audience here, because we have a guy who was early on at Palantir in the audience, and I know you probably have a couple of opinions about whether it's AI or IA and how data should be approached. This is Ari Gesher. He'll be speaking tomorrow morning, but
Yeah, is there a mic I should-
yeah, that's my Robert Goulet. Where are you from?
It's something we've thought a lot about at Palantir, which is how you bring the technology of data science to people who are not data scientists. And I think the place, we've seen an incredible renaissance in the big data technologies, but I would sum all that up as better tools for programmers, so labor savings for people who actually understand how to gain these insights, what it means to get to the data. In the real world, in work with our customers across many different industries, what we've seen is there's a lot of excitement about data without a really good understanding of the difficulties around it, how you get to the point where you can get good signal out of things. And that part of that comes down to people that you know, I like to, like in the early days of big data scaling was all about data size, and that's where the origin of the term comes from, right? Big data is anytime the size of the data itself is a problem, and today, like, scale is less of an issue except for the biggest problems, and the scale point that big data has difficulty with is people who understand how to use it effectively. As a company, we spend something like 50% of our development resources on UX, on connecting the people who deeply understand the problems to systems that help them decode the data, and that doesn't seem to get any easier, right? Building good user interface that translates data into a semantic domain that connects up with subject matter experts, deep expertise on a subject is something that like doesn't, that like the next version of Spark doesn't fix. It makes it a little more interactive. We use Spark all over the place, but there's no question that applying the data science is a competitive advantage, but how you get to the point of connecting to it, I think, is something that we've seen over and over in practice. It's like it's much further than people think. I like your characterization of it as being a long tail. Yeah, how it gets to be part of how everybody makes decisions takes a long time.
And it seems like one of the things that I mean, I'm sure you guys strive to do, in fact, is reduce the risk of users black boxing things. The constant notion of like, I'm going to throw that thing at it because I like that widget, right? I mean, there's a safety you have to build into interfaces. The same way, I mean, things like Excel build in, bits and pieces of safety so that you can't, divide things by zero. It'll tell you that no, can't do that.
Well, do you think that these skills become more commonplace? Are they rare now but will be baked in? The most common data science tool in the world is probably the Excel spreadsheet, and it's getting supercharged now with all this stuff Azure has in the background. Do people become more competent, and does the process improve through that?
I'm sure employers hope so.
Yeah, well, then, you're right. And, Oracle salesmen probably hope so.
Or maybe they don't, because we could sell them another thing.
Yeah. But do you think the literacy will improve and that will change the situation?
I mean, I maintain that it must, that the level of innumeracy that we tend to see and lack of analytical know-how is only bound to decrease over time. I think as increasingly many job functions require it, it'll have to become more fundamental. I mean, maybe that's just, blind optimism.
I mean, I think it has to. I think it's just going to take a long time, and I think today, that's kind of what I'm seeing is that the more you know about how these models work and how you extract the insight, the more you know how little you know, so to speak, right? So people who just use Excel and do things, that's kind of my point, that they think they derive valuable insights,
Right.
but they really don't.
Right.
They actually make the wrong decisions because
Right.
we don't have the right tools and the right competency.
So,
yet.
Or
so
they're
maybe
making
more
more-
written on us as tool makers then?
I think
to-
tools
to-
and the kind of education programs give it a broader view than just statistics or just kind of from data to insight kind
Right.
of program.
Right, well, this is a bit of a sorcerer's apprentice thing. They take some simple tools and pretty quickly they can do what everybody else is doing at this accelerating rate.
Right.
And it's hard to believe now, but like PowerPoint was supposedly a way of making simpler, clearer presentations. And everybody learned a certain level of skill and it became awful. And that's probably something like that will happen, in the simple tools. What's also going to happen, and I see this right now, is things people think of as pretty terrific skills they've got in data science are getting automated at a really quick level. So a lot of the low-level work you're doing now, AWS wants to do that for pennies. And Google is doing that too. So that they might, take on automate out a lot of data science work, which is like kind of bad news for not so great data scientists because they're going to be out of work, but it's fantastic news for people with skills and talents because it frees up all that scut work and lets them do things that are valuable. And I'd like to hear from you two and anybody else in the audience who has an opinion. What do you think will be some data science skills that would be very hard for a machine to replicate, that would be a real value add, that would be the kind of thing you'd want to keep studying and pushing because that's where you can add the most value in the work you do? Yes?
Well, simple word is visualization. It's easy for to get a graph of a data set, but to make it intelligible to your audience who's going to be C-level, who spent time in business school instead of in sort of technical stuff.
coming into Ari's camps, design and UX.
Yeah, and
Consumption.
they don't understand statistics. You have to be able to present something that, and without even using the word statistics, that using the models that they know. An average is a model, but they don't have to know that, and to be able to tell a story, a narrative through the data that a computer can't just give you, because the computer doesn't know things like what your marketing strategy is or something else like that. Like, you still need humans to tie that together and create a narrative to sell to C-level or anyone else.
So you actually hit on something I thought was very, very interesting. You said the computer doesn't know your marketing strategy. And I actually think that that's the biggest thing, is the connection between understanding analysis and its quality and strategic thinking. I think that's maybe the biggest up-leveling regardless of industry.
It gets worse, which is any time that you're working on a data problem that has adversarial humans on the other side, all the statistical methods break down as tactics change. And so you actually have,
plan survives contact with the enemy.
yeah, and this is everything from trading to fraud to counterterrorism. Like, it runs the gamut, and you have to actually have deep predictive thinking about what the other humans are going to do once you discover what they're doing and you shut
When
them
you said
down.
that at first, I thought you meant other people in the company who didn't like the answer. That too, though,
Yeah,
right?
machine learning will solve company politics any day now. No, it's really when
You're
you
not
have to
terrorists, that's cool.
when you have to understand what the other how your data is going to change based on your actions.
Oh, I
That's
see.
something that historical data doesn't.
You're gonna
help you with.
dent the world, what kind of dent's it gonna be, what's it? Okay.
Lateral thinking is
Right.
huge, right?
Sir,
So there's
you're next.
should I?
Go ahead. You're next. Go ahead. Somebody's.
So I'd like to ask a slightly different question, which is that assuming your company, your organization can get organizationally good at adopting this technology, can get good about understanding data, do you think that there is sort of enough first mover competitive advantage to be gained with the tools and the capabilities that we have today, that you can be like Google and sit there with 20% profit margins, replicatable over time?
Yeah, you said the magic word, margin. it's sometimes. I think if you look at certain industries, there are margins to be had for first movers that are remarkable. I think a lot of those are actually in areas we don't think of as traditionally analytic. I think it's in things like waste management and storage and transportation and things like that, as opposed to, say, high finance, where you may be on razor-thin margins.
I'm very wary of the phrase "be like Google," because it's like a room full of guys with Fields medals doing direct marketing. It's like super smart people in a very narrow problem set, right? So they're going to say that a lot. You can be the you can be the Google of public swimming pools, whatever. But I hear this a lot in my work, and I'm very wary of it. What is interesting is, to me at least, is the companies that have really broad data sets and understanding of what the hell it is they actually do, and they're rushing to put sensors out on all of their touch points to improve their efficiency, but also kind of model themselves differently. The most interesting example to me right now is General Electric, which 3 weeks ago sold GE Finance, which was at the heart of GE in the 90s. And that's gone. That era is gone. And now they're throwing sensors on everything and looking at all this service revenues and kind of selling contracts, not just for jet engines, but for the servicing and life of jet engines. They're kind of selling the behavior of jet engines to airplane companies as much as they're selling jet engines. And their feeling is all this sensors will enable them to get a much better margin doing that. They're in the same business, but on this experiential level that is going to deliver a hell of a lot of value. And how can they do that? Well, they really understand their market. They got huge range, and they got huge deep data sets. And so they're willing to transit to this model of essentially being in the behavior business. And I think you'll find corollaries in retail and drugs and military, you name it, where the physical object is a proxy for how you're actually going to get paid. It's the means by which you derive behavioral information. I'm sorry, but this gentleman was waiting. So.
Yes, so there was a little data science startup that has an interesting take on the way they automate data science. I think it's relevant to this discussion. You feed them your data, and they will automatically ask, so have a service, exhaustively ask every possible question of that data. And there's a very large list of questions, but they will only present to the data scientist those answers to some of the questions that seem to be interesting or could lead to insights. And then the data scientist will discern between those answers that look interesting but are actually phantom relationships and others that do relate to insights. And I thought that might be an interesting way for data scientists to work in the future. A curious point, because most of those failures for data scientists tend to be of the sort of data scientists failing to ask the right question or failing to ask the data the right way. So what do you guys think about that?
Yeah, I've been trying not that particular technique, but we're trying to ensemble techniques and things like that. And I think that's a possible avenue because as a data scientist, also you if you look at what's taking a lot of time, for example, at Twitter, I know there's a whole stable of science. They're trying a lot of different algorithms and trying to figure out which ones are working and which ones are not. So it's very, very time consuming. I think in terms of reducing the time and maybe enabling a smaller group of data scientists to get the same impact, that kind of systems might be useful.
Well, it's similar, I think, to what you said, right, in terms of getting rid of the scrubby stuff.
Yeah, it's also sort of like an interesting sort of meta view. They're automating a lot of data science work and saying, hey, this is something where a human should get involved.
Right.
This is where your core skills really might add some value here. That sounds very promising.
We're going to have to wrap up. Okay.
But he had a question.
One last question.
One last question. I'm sorry, but this gentleman, before you.
Just going back to the topic of tail and that it takes time to make these changes. But I'm wondering if that applies more to the companies that are not set up to make the data easily available. They don't have the infrastructure of knowledge of data scientists, and they're slower to react because of the internal politics, but the internal infrastructure is just not there to allow that speed. But if you take a new company that doesn't have all these barriers and to start from kind of almost from scratch, it's not a Google model, but it's the next Google, right? It's the next out of the box thinking that we haven't considered. I'm wondering if those really are going to have the same long tails as the past, right? Because you're not up against the same kind of constraints. You should be able to take off faster, and therefore the impact to a new company would be much more significant because you could displace the current competitor that just can't move as fast.
Well, I think you make a very good point. When you have less organizational friction, this is definitely more possible, and you can shorten the tail. But I think we have to balance the fact that as a new company, you may maybe have less organizational friction, and you can make this stuff institutionalized much more quickly. But you're also going up against capital. And if you go in and say we have no organizational friction, and we're going after GE. GE has a lot of money. and you know what beats democratization of data in the short term? Money.
I'm sorry to say we have to wrap this
sorry,
very
it was
interesting
great fun.
conversation.